welcome to 6G. This is modeling in application projects. So, day 0 of a tree. I have a tree, day 0, it is 910 centimeters. So the first time I've ever measured it, day 0, it's 910 centimeters. I now measure it a day later because I'm like that. So not day 0, day 1. It's, 910.1 centimeters-ish or whatever. But let's say I ignore that for the rest of the year. Let's say I put the tree out there and I leave it because the change is too small to notice each and every time, and I could be making a mistake when I'm measuring it. Let's say I come back after a year. And then I measure the tree. So, so this is day 365. So 1 year. The tree is now 923 centimeters. Over the course of a year, how much has that tree grown? Over the course of the whole year, how much has the tree grown? How much has the tree grown over the course of the year? Yeah. So it's gone 13 centimeters. From 910 to 923. Well, if I then skip ahead to 2 years, and it is 36. What's the growth between those 2 years? It's still 13. Does anyone want to make a prediction at the end of next year? After 3 years, it's going up 13 centimeters each time. What's the next number going to be? Yep, 949 centimeters. There's another 13. So, what we need to do is we need to create a linear model that represents how this tree is growing. All right, and we are going to use this model to make predictions about the future. So, looking at this information, we need to set up a equation. Y equals A plus BX. Now, remember, B is the rate of change. What is changing how much is it changing by every year? It's changing by 13 centimeters. So that means that my B value is actually going to be 13. Because it's day is 0, 1, 2, 3. Every year it's changing by 13. So B is going to be equal to 13. Y equals A plus 13x. And by the way, x is time in years. X is time in years and Y is the height of the tree in centimeters. So I now have y, the height of the tree is equal to a plus 13 times the number of years. 13 times the number of years is how much it's grown. But what is my a value going to be? All right. A is actually going to be the intercept. It's going to be when x equals 0, when no time has passed. When x equals 0, y equals a. But we also know that when x equals 0, because it's over here, day 0, y is equal to 910. Therefore, a must be equal to 910. Which means that I can now write out a full equation for the height of the tree. Y equals 910 plus 13x. I'll just do that 10 a little bit better. From that, I have now created a linear model, and I can use this model to help me predict how big the tree is going to be after a certain number of years. So, on your calculators, I want you to tell me when x equals 4.5, what is y? When x equals 6.7, what is y? And then I've got a challenge. I've got a challenge for you all. What is x when y equals 1,000? All right. So when x equals 4.5, Casey, you've said it is 968.5. Does anyone disagree with that one? Now remember, this is in centimeters. So it's 13 times 4.5. So it's 13 times 4.5 plus 910. Yep, so I got the same answer. When it's 4.5, it's 968.5. When it's 6.7, what do we got there? 997.1. Now, here's the challenge. How do you work backwards? You have the answer. How do you find the time? All right. Heather, you have given me the answer of 6.92, which I'm relatively confident that you're correct. Do you want to explain how you got it though? Because I would like an explanation for how you got that answer. Yep, so 1,000 minus 910 is 90, and then divide by 13. 90 divided by 13 is 6.92. That is correct. Well done. Well done. That's what we want to see. All right, so using these linear models, you can work forwards or work backwards to solve these sort of problems. So, the next thing we're going to look at is a model, but we're going to use our CAS to help us out. So, we are looking at 6G, and I'm going to ask you guys to open up and have a look at question 5. Question 5. So this is another financial maths question, but it's a financial maths question that links into the stuff that we're doing right now regarding linear modeling. And this sort of thing will become relevant if you continue on into Unit 3 and 4 next year, which I certainly hope that most of you do. So our CAS is going to help us with this one. All right. A business buys a new photocopier for $25,000. Those photocopiers that you see in the staff rooms, yes, they do in fact cost around $25,000. They are not cheap at all. It plans to depreciate its value at this rate per year for 5 years, at which point it will be sold. All right. Let V be the value of the photocopier after T years. So, if something is depreciating, what do you think that's doing? Is that increasing or decreasing in value? So if something is depreciating, yep. If something is depreciating in value, that means it is going down. All right? So it is going down by 4,375 per year. Yeah. We're all pretty unanimous there. It is decreasing. So, when they buy the photocopier, how much time has passed? When they buy the photocopier, how much time has passed? When they buy it, I mean. When they buy it at the start. At the start, when they've bought it originally, how much time has passed? Nothing. No time has passed. So, when T equals 0, because it's asking us to make V the value of the photocopier and T being the number of years. So after T years, i.e. they literally just bought it, V is equal to 25,000. So this is useful in that it automatically allows us that we know something about it. If my X value is 0, my V value is going to be my intercept. And that means that I already know what the A value is for my linear model. So, using V, T, and what I know, so normally it's going to be V equals A plus BT, but I know that when T is 0, V is that, therefore A is also going to be 25,000. Now, T is going to be my number of years. All right? So T is my number of years. We're going to put that out there. What's the change every year? Now, is that up or down? How do I represent down on a gradient? Is it a positive or a negative gradient? So a couple of people there. Negative, negative, negative. Beautiful. So I'm going to put a negative in there to show that it's decreasing. And it is 4,375 t. So I now have a linear model that answers this model that I've got up here. So sketch the graph showing the coordinates of the intercept and its end point. What do you think the end point is going to be? When is the end point going to be? What value of t do you think it's going to be? Final value? All right. Can something have a negative value? All right. If I were to, I'm going to do a very, very, very quick sketch of what this situation looks like. 25,000 years here. This is 25,000. So as you can see here, I have a linear graph here, and there's my value at the start here, and then I have a value at the end here. What is this value here? What is the actual value of the photocopier at this point here? Thinking about my axis, what's the value here? Yeah, it's 0. So after t years, the value is now 0. Do I need to worry about the graph beyond that point? No, because I can't have a negative value. So my graph is going to naturally want to end at that point there, where all of a sudden the graph is valued at 0. I no longer need to worry about the rest of it. So the question is, where is that point? So to do that, we're going to get out our CAS and we're going to draw this graph. All right, so first things first, let me bring it up on the screen for you guys. Let's bring up window capture this one, and we'll bring up, no, excuse me. Bring it over here. Take away the success criteria, and I will shrink my buff head. I'm all nice and small. So, so we already have our equation. Great, grand, done. So what we're going to do is we are going to, first things first, clear away all these ones that we don't need. And we are going to type in our equation. 25,000 minus 4375x, because this doesn't work in T's and V's, this works in Y's and X's. But we're going to have to mentally make sure that we remember that Y is V and X is T. And I'm going to draw the graph. Where is my graph? Guys, where is my graph? I know where it is. Do you know where it is? What do I need to change about my graph so that I can see things? What am I going to need to do to my graph or do to my calculator so that I can actually see this lovely graph I'm trying to draw. Oh, I've hit the draw button, and it's gone. It's all gone. What do I need to do? What do I need to change about my graph? What do I need to change about the way my graph is set up? All right, remember, you've got this window button here. We need to change the window button. We're going to go -1, and we'll say 10 years, just as a prediction. But see here, the Y maximum is only 11.8. We're dealing with 25,000. So let's go to 26,000. And there we have a lovely graph. So at the top here, that's 0, 25,000. And all the way down here is its end point when it is worth nothing. So how do we find that point there so we know when it is worth absolutely nothing? All right, so we need to go to analysis. Actually, no, we can do that. You can do this even easier. On your calculator, you'll see a button along the top that says y equals 0. Press y equals 0, and it will give you an answer of, see here, 5.7142857. We now have an answer. So after 5.714 years, the photocopier will now be worth nothing. All right, so it says round it to 5.7143 for the sake of ease. All right, so now we have some idea of what our graph looks like, and I mean obviously if you can see on here, you know, not bad, not bad, not bad. Just a little wonky. That's all right. All right, so we now know on our graph here that it's 5.7143. So they plan on selling it after 5 years. So after 5 years, when t equals 5, what is the value of it when they sell it? What's the value going to be for when they sell it? So when t equals 5, on your CAS, what we can do is we can go to analysis, gsolve xcal ycal. So ycal, what is y when x is 5? And it tells me right there, $3,125. So if you were to draw this graph, you would say, well, if they're going to sell it after 5 years, that is an important point for you to measure. And then your second important point would be at the start, and then you would probably also mark the end for when it's absolutely worthless. So the other thing is we have to now use this model to predict 2.6 years. And again, we can do that with analysis, gsolve xcal ycal, go to ycal, and remember x is the number of years, so if we say x is 2.6, it tells us that the value is $13,625, and then you can press EXE on that to mark it in place. And then I'm going to and then here you can move along the graph, measuring time and space and all the wonderful things in between. All right, so 6G happens to be split up into like 1, 2, 3, and 4. So right now you are focusing on 6G part 1. All right, and next week we'll look at 6G parts 2, 3, and 4.